Parallel and perpendicular lines. The primary purpose of this video example is to introduce you to something called zoom square on the calculator. It's a different zoom mode than we've previously used, since we've really only used the zoom standard mode. We'll get introduced to some others down the road. But zoom square has its purposes, and we're going to see one of those here. So in our example 1, we're asked to graph three lines. Y is equal to 2x minus 5, y is equal to 2x plus 3, and y is equal to negative 1/2 x. And we're asked to graph them initially in the standard window. So let's go ahead and do that. Alright, so I'm going to clear off the stuff that I was doing before here, and we'll go into the y equals menu. I'll clear out any previous equations that I have. And I'm going to put 2x minus 5 into y1. So I'll press 2x minus 5 and then enter to store that into y1. And then our second equation, y is equal to 2x plus 3, store that in y2. So I'm going to type 2x plus 3 and press enter. And then finally we have one remaining equation, negative 1/2 x. And I'm going to type this by putting the fraction in parentheses as I've done previously. So I'm going to type negative, and then in parentheses 1 divided by 2 to represent 1/2. And then I'll close that parenthesis, and then we'll type in the x. And press enter. So we have these three lines stored. And again, we're asked to graph them in the standard window to begin. So we're going to press zoom and choose option 6 for the standard window. Now our calculator will graph them in the order we entered them. So it's going to graph y1 first. So the first line we see coming up on the screen here is 2x minus 5. Then it's going to graph the second line y2, or 2x plus 3. That's the second line we see coming up here on the graphing screen. And finally it's going to graph the third line, y is equal to negative 1/2 x, because we put that into y3. And that comes down through here. So we have all three lines up. Now, if we look at the first two lines that graphed, y is equal to 2x minus 5 and y is equal to 2x plus 3, on the graph it looks like they might be parallel. And if we compare their slopes, we'll see that their slopes are both identically 2. And anytime two lines have exactly the same slope, those two lines are parallel to each other. So they're parallel and they look parallel. Now, if we take a look at this third line, it looks like it just kind of comes through here at some random angle. But if we apply our definition of perpendicular lines, we know that two lines are perpendicular if the product of their slopes is negative 1. So if we take 2 from the slope of the first line and multiply it by negative 1/2, the slope of the third line, 2 times negative 1/2 is exactly negative 1. So according to our definition, these two lines are perpendicular, but they don't look it. And the second line also has slope 2. Multiplying that by the slope of the third line, negative 1/2, also gives us negative 1. So we should have two perpendicular intersections here, where the line that slopes down from left to right crosses the two parallel lines. But it doesn't look that way. And that's a function of a couple of different things. It's a function of the window that we choose on the calculator. And it's also a function of the fact that the calculator screen is wider than it is tall. But what we've told it to do is to represent a total of a distance of 20 from left to right, negative 10 to positive 10, and a distance of 20 from bottom to top. So this 20 is actually longer than this 20, if you will, and that tends to skew our picture. This is where zoom square comes in. What zoom square does is it modifies things so that the distance between tick marks, in this case, as the tick marks all represent 1, is actually the same whether you're going up or going down. So if we press zoom and choose option 5, square, it's going to regraph our lines. And what it's done in this case is it's actually left the y part of the window alone, and it's expanded the x part, so there are more x values involved in the window now, so that they're a little bit closer together, in the same way that the y values are fairly close together because they represent that shorter bottom to top distance. So there are two parallel lines, and if we wait a moment here, our third line, which we know mathematically is perpendicular will come through. And now it looks perpendicular as well. So two kind of points to take away from this. One is obviously the zoom square. If you are graphing circles, then circles typically tend to look like ellipses or ovals until you zoom square. So that helps with circles, it helps with other things. But maybe even more important than understanding the zoom square function is to understand that because of the way we can change the window and kind of stretch and pull the coordinates and the axes, what you see isn't necessarily what's really going on if we're able to do everything very nicely um, as we would potentially on graph paper. All right, so that's an advantage of the calculator, that we can do that with the window, but it also causes us some grief once in a while if we take what we see on the screen a little too literally. So please be careful of that. Anything you do with the calculator, please be careful of what it does. It does help us with a lot of things, but technology always has limitations, and we need to be very well aware of those. And that's another purpose to this video, is trying to make you aware of one of the viewing limitations of the graphing screen.